Hi guys, can you hear me okay?
Hey Fred, I hear you great.
Yes, we
Great.
can.
I'm pulling up the video. Let's see what happens. Hey, I think that may be me.
There you are.
Doug, you're a neurologist?
Yes.
See, I
I
didn't know that.
I started life as a nuclear engineer. I did my first job as a Navy
Yeah.
submarine officer and then went to med school.
Now you get to come full circle.
I mean,
Oh,
this stuff wasn't happening back in 2000s. It would have been great, but
yeah. Yep. I get it.
yeah. You've had a lot going on since I saw you in, I think it was December in Florida.
Yeah, we're keeping busy. We got some good work going on. I'm pleased. So hopefully we can hopefully we can leverage that into more resources and get to the end. I think we can. So
Yep,
that's going to be that's going to be a real push here is to try to really make hay while the sun shines with with the work we got for Space Force, and I think we can.
makes sense.
Yeah,
Did you get my email with the list of questions?
I sure did.
Great.
Are we live now, or how are we doing this
I think anyone joining can hear us.
right now? Okay,
We haven't started, officially, but I think our voices are public, so to
they're
speak.
hearing us. Okay, that's all right.
Exactly. Aiden, I'm going to let you track the attendees and let us know when we should kick off officially.
Sure. Yeah, we still have people funneling in, so let's just give it, maybe 2, 3 minutes, and we'll get things kicked off.
Great.
How many folks did you pick up for this? Did they have to go ahead and reserve in advance, or how'd that work?
We had some people RSVPing. We sent invite out to some of our guests who like to continuously come to these,
Yep.
and we got a good healthy number today, so it should be a good time.
All right, I'll let you tell me later how many that number was. I'll be right back. I'm going to go grab myself something to drink.
Sounds good.
Guys, also let me know if this is working out from the audio because sometimes my cute little contraption here doesn't do what it should.
We hear you very clearly.
Cool.
Okay, Fred, if you're ready, I think we should get started.
All right. I am ready. I'm good to go.
All right. Good afternoon, everyone. This is Doug McAdams, advisor at Valerian Space Ventures. Today we're hosting Fred Kennedy, Dr. Fred Kennedy, who's CEO of Dark Fission. They're making a nuclear thermal rocket or reinvigorating nuclear thermal propulsion. So thanks for coming, Fred.
Thanks, Doug. Appreciate you bringing me on.
I was thinking we could maybe start big picture and then drill down into the specifics of what you guys have going on. And I was wondering if you could just start by telling us your background and how did you get into NTP?
Yeah, not a problem. I have to admit, this was not something I'd be coming back to, sort of this late. I first ran into this as a senior in college. We were doing just a space systems engineering design course, and we were looking at what NASA was trying to do to get to the moon and Mars. This was when the first President Bush had suggested we're going to go back to the moon and Mars. And I was like, my God, I couldn't be luckier. We're about to go do some pretty amazing stuff. This is back in the early 90s. Um, I looked at the problem, looked at what they were doing, looked how expensive it was for what NASA was trying to do, and I recommended nuclear thermal propulsion. It cut off all the logistics. It made all the travel cheaper. It made it look like it would close at a much smaller number, and that got some attention. It turned out it got some attention not from NASA so much as over at DoD because the technology that I actually recommended was something unbeknownst to me that was being worked on by the Department of Defense at the time in a classified manner. So I got a little bit of hearing from here, there, and everywhere because the program at the time was coming under, a lot of fire because it was into the Cold War, and the stuff they wanted to do wasn't going to be enough to keep it alive. So they were looking for other ways to keep it going. Um, I got introduced to that. I ended up doing my master's degree work in that. I ended up going to my first assignment to work on it, watched the program collapse there, and then told myself I'd never get involved again. And then it turns out I kept coming back to it. Um, and I guess the most prominent element of that was in 2018 or so when I was running an office at DARPA, and I got a call from Lieutenant General Steve Quast, who was running Air University, and he said, "Fred, um, if I had to go really fast around the space between the Earth and the Moon, if I had to really get places quickly, really be able to project power and do stuff I really wanted to do, completely different from what we do today, which is basically nothing, how would we do that?" And I thought about it for a second. I said, "Well, nuclear thermal propulsion. I mean, that's the way we'd have to go. That's what we'd have to do to basically meet the kind of timelines and needs you're talking about, boss." And he said, "Well, then why aren't you running a program like that at DARPA? Why isn't that a program? I don't see that anywhere." And I felt sufficiently chastised that I sat back for a bit and talked with some folks, and we stood up a program. We called it Reactor on a Rocket, ROAR, and launched that off. And then I headed off to, somewhat greener pastures, standing up a new federal agency to do small satellite work. But that program became something that was then called Draco. And the Draco effort just got canceled here recently, but that was the outgrowth of what we started with ROAR back in 2017 to 2018 timeframe. In terms of myself, why I'm working on it now that I'm out of the federal government, well, I've been through a couple of startups, decided I didn't ever want to work for anybody again after those two efforts. Said if I was going to do anything else, I was going to work for myself. I had a buddy, old friend, 30 years, call me up and say, "Fred, what are you doing now?" I said, "I don't know yet, but it's going to be my own thing." And he goes, "Well, why aren't we building the nuclear thermal rocket?" I said, "What? With what? With a startup?" And he says, "Yeah." Because why aren't we doing that? You keep saying that there's a bunch of private money floating around out there to solve these problems that the government is crap at doing. So why don't we do that? And while I thought he was totally out of his mind, we sat down, looked at the problem, decided it could be done, and jumped in with both feet, created Dark Fission, and we've been on a roll ever since. So that's uh, that's kind of where we got.
Well, the timing's good because these two things have gotten interesting lately. You've got the space economy and you have this nuclear renaissance that's been in the news and 10, 15 years ago there wasn't a lot going on and now both of those things have picked up quite a bit. So just zooming out, what do you think about this so-called nuclear renaissance that's in the news? Just the idea of microreactors, small modular reactors, getting the uranium supply chain going again. How does that fit into everything?
Well, I mean, it all kind of grows on itself, yeah. The fact that we're seeing small modular reactors being pushed for any number of applications, whether they're civil or defense or what have you, is fantastic, and that's something that can be leveraged. It can also be leveraged the other direction. Any good work we do on the space nuclear side can be leveraged back to the things that are going terrestrially. So I love it. I love the fact that it's out there. The truth is, we do need the power and energy density that nuclear provides. We've been kind of stymied for decades trying to figure out how to get beyond fossil fuels. And while I love I love the thought of wind and solar. They have their part, but the very high power densities that you can achieve with nuclear are what's going to allow us to really keep jumping ahead in the future. Um, and that's the same in space. We need those power and energy densities in order to do pretty much anything that we want to do. If we want to go fast in space, if we need to go efficiently in space, if we need to power habitats and mining operations, whatever we might intend to do out on celestial bodies like moon, Mars, or asteroids, anything like that. If we're ever going to do that stuff, we've got to graduate to nuclear. We're not going to be able to do it with basic chemistry and sucking up photons. It's just not going to happen. So yeah, I'm
Right.
a big fan, and I'm glad to see that there's a lot of energy in this. There's a lot of energy in what we call nuclear batteries, radioisotope thermoelectric generators. Now we're hearing NASA's really entertained by the idea of putting a fission reactor on the moon, which makes perfect sense because moon has a very interesting issue with lunar night, and there are only so many ways to deal with that, and one of them would be to have something that doesn't care about where the sun is any given point. So.
Right. Yeah, I would totally agree with that mission. And I think a lot of people intuitively understand nuclear energy, both on Earth and in space. Just making electricity with nuclear power, it's orders of magnitude more energy for a tiny amount of fuel, and that's very intuitive. And so you have the making electricity, but then you have NTP that you're doing, and that's a little different. So can you tell us what NTP is and how that works?
Absolutely. I mean, what I just talked about is primarily the power applications, right? You want to generate electricity, whether you're on the planet or somewhere else. Think powering spacecraft or rovers. Um, but that's not what we're talking about here. Nuclear thermal propulsion is propulsion. It's a rocket. We're going to use a nuclear reactor to superheat a propellant. That could be hydrogen, could be a bunch of other things, and then expel it for thrust, like rockets you see, on the news every day. Uh, the value here is that if I use a nuclear reactor to heat that propellant instead of combustion, it's a whole hell of a lot more efficient, which means I don't have to use nearly the amount of propellant, and it's propellant that's expensive to get up on orbit. You look at something the size of Starship, you're talking about 1 million kilos of stuff that you got to get the little bit on top that goes to orbit. We would take anything that a Starship or a New Glenn or anybody else comes up to orbit with, and we'd get it anywhere else to the moon, other orbits, planets, you name it, for far less propellant, which means far less money and far more quickly than you could do it any other way. So that's the value. That's why we want to do it.
Okay, that makes sense. The chemical rockets get us to orbit, but my understanding is that if you tried to use those to routinely go to the moon or go to Mars, you'd have to refuel them several times, right?
Yeah, I mean, you're looking at Starship right now has been working with NASA on how to get to the moon and come back, and they want to land Starship on the moon, and that's a pretty big item. So in order to do that, they're going to have to look at refueling Starship 10, 15, maybe even 20 times. I'm not sure anybody is exactly certain at this point what the actual number of refuelings will be. Um, I've done refueling on orbit, and it's one of those things that kind of keeps you puckered up. So the idea of doing it 15 or 20 times before all your propellant boils away, I think that's sporty. And so what I would say is, why not take a page from the intermodal transport solutions we have on Earth? We don't have to send container ships everywhere on the planet. They don't park themselves at every Walmart, every McDonald's. They deliver to ports, and at the ports they get on trains. Connex boxes are unloaded and stacked. They're put on trucks, and those go to their final destination. Same thing applies here. Chemical is absolutely amazing for getting off the planet and getting into low Earth orbit. But once you get out beyond that, you really want to achieve efficiencies you can't get, with chemical to get yourself around. And that's where nuclear really wins out big. And I think the intermodal story is the right one. You use chemical to get up there, and then you use nuclear to get everywhere else. And I think that's going to be the story of how we expand our economy and ecosystem into the solar system.
Okay, so chemical gets you up to orbit, and then nuclear gets you these distances once you're up there. Is that what you mean when you say intermodal?
That's what I mean. I mean, there's nothing that says you can't use chemical or electric propulsion or other means to get around, but we've been using chemical propulsion to get around the solar system for the last, 60 plus years. And it is a game of billiard balls, orbital mechanics, and frugality because you just don't have the oomph to do the kinds of things you want to do. It takes you 9 or 10 years to get to the outer planets. It takes us a lot of time to get to Mars. We don't want to do that. We want to be able to get where we're going rapidly. We want to get there efficiently. People always prefer FedEx over slow boats to China, pretty much any
Right.
day.
Okay, so once you're up in space, your nuclear thermal propulsion that you're talking about kind of has best of both worlds. If you've got chemical, you have these giant fuel tanks you have to keep refueling. If you use nuclear electric propulsion like we do for satellites, you can get there, but it's going to take you a really long time. And your system gets you both thrust and uh, efficiency, I guess.
Yeah, I mean, think of it, I like to talk to people who don't do rockets on a daily basis. It's kind of like gas mileage, right? You could
Okay.
you could look at it as a car analogy. I know my good friend Bobby Law likes to talk about it this way. I will maybe disagree with the kinds of cars we'd use, but what I would say is that chemical's a big old gas guzzler, right? And it gets you to low Earth orbit just great. It gets you there real fast, high thrust, does its thing. But it's profligate. It expends a lot, and it's going to be expensive to get up and do that. Nuclear electric, you can kind of think of it as, I would say call it the electric car here. There's nothing wrong with the electric car, and certainly we've seen Teslas and others manage to really pull a whole lot of performance out of them. But in classical terms, the electric car might be, say, working efficiency over performance. Fine, but if I need to get somewhere, for example, if I need to get to the moon in a day, nuclear electric won't. It simply won't. We would have to have megawatts upon megawatts of power dumped into a system to allow that to occur, and nothing like that is on the horizon. If the Space Force wants to get to the moon or lunar orbit in a day, nuclear thermal is an absolutely outstanding option to go do that. If Elon or NASA or somebody else wants to get out to Mars in 60 or 90 days, nuclear thermal is the option. Nuclear electric is going to be a much tougher sell for those kind of missions. They're typically very, very low thrust, but again, very efficient. They sip propellant, which is great, but take a real long time to get where they're going.
Okay, and then and so you've got this you have a nuclear, nuclear is your source of heat, and then your rocket fuel is liquid hydrogen.
Yeah, we would opt for hydrogen. That's the best performer from a rocket standpoint. That doesn't mean we can't use other propellants, but we would have, less performance if we were to go with them. So you could look at options like ammonia or water, methane as well. All of those are options. They all have their advantages and disadvantages, but hydrogen is by far, the best contender because it's the best propellant from an efficiency standpoint.
Okay. And if I have it correctly, I think the latest NASA technical reports on the Mars architecture have NTP as the method to go to Mars. Is that correct?
Well, I'm not sure they actually ever made a determination on that. It seems
Okay.
like they kept carrying both nuclear electric and nuclear thermal. And I looking at the last set of studies that came out, I don't think they actually made any kind of final determination. They just said pros, cons, and
Okay.
here's where we are. But no, I don't think anybody's ever settled on that. And as to how we get to Mars, there's many ways to get to Mars, and we probably ought to look at every one, last one of them.
That makes sense. And would your system be sitting up there waiting, or is it like an upper stage that goes up and then the upper stage takes off?
Well, when the DoD looked at it back in the 80s and 90s, it was an upper stage. That's
Okay.
exactly what they were looking at. But that was going to be used in an environment where no one probably would have cared. So
Okay.
uh, so not so much the problem. But now, yeah, we would only operate this reactor and engine on orbit. It would not be an upper stage. It would be what we would call a space tug or ferry, and it would meet Starship or New Glenn or any of these other launchers that would come to low Earth orbit. It would meet them. It would essentially dock with a payload pallet. It would grab propellant either from a depot or from the actual launcher, and then it would go about its business. It would go out to its destination orbit, fire its engine up, head out, drop off its payload, and then come home and then do it again and do it again and do it again safely, reliably, not entering Earth's atmosphere. We don't want to do that, and there's no need to do so. We would only operate in space.
That makes sense. And sometimes when we talk about topics like this, it's hard for people to separate, kind of science fiction or far out things from practical things that we can do now. And for NTP, this isn't something new, and we had started building this decades ago, right?
Absolutely. Yeah, we've been looking at this concept for longer than I've been around alive. The work was done by NASA back in the 50s, 60s, eventually canceled in the early 70s, called rover NERVA. And they were looking at a variant of the kind of system that Dark Fission, our company, our startup is working right now. Um, they did a lot. They progressed very far, and the only reason they stopped was because the Apollo program got canceled about 1973, and pretty much took down everything with it. And this was one of those activities that was going gangbusters, and we were very close to having a flight ready system. I will tell you right now, anybody who looked at that program would say you weren't more than a few years out from being able to field something. But at that point, that was a decision that was made at the highest levels, and that came down. So a lot of work
You
has
had
been.
ground tested a rocket, right?
They ground tested multiple rockets, absolutely, and they did it in a way we'd never do today. They went out in the desert, out in Nevada, and they mounted a rocket, pointed it straight up with a reactor in it, out in the desert, and just fired propellant through it. And I would not recommend that, and I will never recommend that today. But that was what they did, and they had some very successful tests, and then they had a few failures. In fact, one of their tests, they actually tried to blow up the reactor and rocket. They wanted to see if they could. I can't imagine us doing that now.
What's the concern now?
Well, I think at this stage, we recognize that there is environmental impact to playing with nuclear reactors, especially out in open air. We're not going to do that. In fact, we don't intend to ever light up a reactor on the planet at anything but extremely low power in a DOE facility, just to make sure it works at all. The first time we really turn on our reactor will be on orbit, so it'll be inert and safe while it's being carted out to the launch site, while it's launched, and pretty much until we actually activate it for the first time.
I feel like we're seeing that a lot in the space economy, where they'll take the first prototypes now that it's easier to get up to space and you can do your initial tests in low Earth orbit.
Yeah, actually, I'm pretty much wedded to that approach now. I think the right answer is to get to space as quickly as you can with whatever you can. Make sure you can get the piece parts working, and then rapidly grow your capability. I think we've learned that over the past couple decades that is the way you learn. You don't just sit on the ground and keep fiddling with tech and sandboxing. You've got to get up and fly and demonstrate that you know how to do it, even if you don't have it all perfect and ready to go. So that's what we're going to do. That's exactly our approach. We're going to get up there with some simple stuff to start, culminating in a full up reactor after a few flights. So
Just the rapid iteration SpaceX approach.
I think you got to do that. If you don't do that, I think you're just condemned to long, protracted programs that end up costing you too much money, and everybody just says, "Hell with that." So,
Right. So are you evolving NERVA, or have you kind of started your own design?
I'd like to say we just started our own design. It's not NERVA though. We're not going with the NERVA approach. So for everybody listening, NERVA was the program that NASA conducted, in the middle of the last century. Uh, some good stuff learned there, and a lot of that was looked at during DARPA's Draco program. Um, Essentially a derivative of those kinds of concepts. But we're not going there. We're actually glomming on to something that was done by the Department of Defense in the late 80s, early 90s. We have something called a particle bed reactor. Think of it as a bed of sand, and we're just pushing gas through the bed of sand. The bed of sand is the fissile material, the uranium. It gets really hot. We push the gas through it. The gas gets really hot, and we push it out the back. And that's how we make thrust. That's how we make our rocket go. So it's a very elegant concept, but of course, as always, the devil is in the engineering details. So what we need to make sure of is that we can actually build the darn thing, that we can get something this hot, and that it'll stay together, because there aren't lots of materials that want to survive at these temperatures for any length of time. So that's really our key goal is, okay, can we build the components of the reactor we want to build and have them cycle and cycle and cycle to the high temperatures in hydrogen propellant? And if they could do that, then we got a working system, and I'm going to be very confident. So we're going to start putting pieces of that up with our very first flight demo, which we're calling Dark Scout for obvious reasons. And that's going to put up some fissile fuel to start and try to heat it up and push gas through it, just to demonstrate that we can do that. And we can do that without ever having to go critical. But it does let us get through some regulatory gates at the same time, and it satisfies a whole lot of things we need to do to show that we can fly.
Oh, cool, cool. And what fuel are you using?
So,
HEU, HALEU,
so for everybody out there who's not done, nuclear fuel development or has any familiarity with nuclear reactors, there are grades of fuel. You've got highly enriched uranium, which people tend to think of as weapons grade, although it could be as little as 20% of the fissile material in the fuel. We're going to be using something called high assay low enriched uranium, which is HALEU, right around, just right below 20% fissile. It turns out it's a good compromise because it doesn't come with all the crazy security and sanity that HEU does, but it's still good enough that you don't end up with a big bloated reactor like you would if you had to drop all the way back to sort of commercial grade fuel, which is just a few percent of enrichment. So that's why we like it. It actually turns out it's great for our specific design, and we end up with a very, very lightweight, compact core, which is exactly what we wanted, and it works great with HALEU. So,
okay. And how do you feel about, it's a little sidebar, but how do you feel about the supply chain shaping up now for HALEU?
I don't like any of the nuclear supply chain. It would be much better if we could just go out on the international market and grab what we want. But, in the wake of Ukraine and Russia and all the rest, it's gotten a lot tougher. So, we are looking to look at resources like, say, DOE downblended capability. There's stuff that's existing in, current DOE facilities that we could go grab and essentially de-enrich it so that it goes all the way down to sort of the HALEU classification. We don't need much. A lot of the companies that you're chatting with, they'll need tons of this material. To do this, I need 50 kilos. I mean, I just need scrapings off the table. So whatever everybody else wants, just let us have a little bit at the end, and we can easily go do our demonstration and fly missions with very little fuel, which I think is a big win for us, and we'll be able to press forward.
And it sounds like, a lot of the companies that we've worked with, if you're working with the DoD and you have that mandate, it kind of gets you around a lot of the roadblocks in terms of getting access to that. Is that correct?
I mean, I think it's going to help if you've got somebody like DOD acting as a brickbat to walk in and say, "Hey, we really need this mission." So yeah, I won't deny that. But I also don't want to rely on it. We want to be a commercial company. We want to provide transportation as a service to everybody who wants to go fly. So we need to be able to make our way in the commercial sector without relying on things like indemnification from DOE or DOD. Without relying on people to stand up and say, "Hey, put us at the head of the line for fuel." I think we're going to get the fuel. I'm not particularly concerned about that. We don't need lots of it. We're in the HALEU consortium. We'll get the fuel we need one way or the other. And then we'll get folks to make sure it's in the right form factor, as particles. There are a lot of people out there right now that can help us with that, like X Energy and General Atomics and BWXT. There are players out there who can help us. So that's all good. So while it's an issue, Doug, I don't think it's a showstopper in any way.
No, it seems like there's a lot of demand for it, and the supply is moving fast to get there.
I agree. By the time we need it in the next few years, I think it'll be just fine.
Yeah, it seems like it.
Yeah.
So I'm going to catch up. I've got a few audience questions here. We'll get through, and then we can get back on track. So the first question is, what's preventing you from flying your NTP system, or maybe do you have any roadblocks to flying?
Money. I mean, I can do a lot with resources. It's much tougher without. So yeah, I got a couple $1 million right now. We got a $500,000 from a corporate player a few years ago to do the conceptual design, but I got a couple million to do some very serious tech maturation on the key piece of our reactor, and we're making great strides towards that right now.
Is that your NASA SBIR?
Space Force.
Space Force, SBIR. Okay.
Yeah, we don't have any NASA money right now. I certainly wouldn't mind getting it at some point, and we've been talking a lot with the NASA crowd, both at headquarters and down at Marshall Space Flight Center, where a lot of their nuclear thermal work is. But no, right now we don't have any NASA dollars at all. We're working off a small business innovative research contract with Space Force, who see the value add to having fast, efficient transport between here and the moon. Gee, I wonder why they want to do that. So it's good stuff, and I'm very pleased that we have it, and yeah, we're moving out. So
And
in
some
terms
people
of
might
what we
worry.
need to do a demo, yeah, I'm going to need money to do the demo. I think I'm going to need 5 million or so to do our first demo, and then it gets more expensive after that. So I think resources are probably the thing that are the most most concerning to me. We know how to do this. The technology isn't wacky. The steps are known. I've run numerous space programs. I know how this is supposed to go, and I know how we could do it quick and agile. We just have to get the resources to do it.
How about regulatory?
Regulatory is an issue, but what I would say is there's a lot of people now who care, and they're doing everything they can to streamline. We just saw, I believe, an executive order pop up on categorical exclusions for a lot of the NEPA and other things that have been difficult for companies to deal with. Hey, if you're a big company, you can deal with all this paperwork, but scrappy startups, man, I do not have a staff of people sitting around waiting to address every bureaucratic requirement that gets handed our way. We are jacks of all trades at this level. So those are energy barriers that we'd rather not have to contend with. The good news is I think the Federal Aviation Administration, FAA, recognizes the value of getting space nuclear up and running on the commercial side, and they have put out documentation to suggest that they're more than willing to work with us, and we have been working with them to get a submission in for our reactor and our system. So I'm not worried about regulatory in the sense that it's going to halt us, but it is something we've got to pay attention to. And as myself and my founders have said every day since we started this, um, what we want is a regulatory cadre at Dark Fission, probably sitting here in the Northern Virginia area to make sure that we're always on tap to talk with folks at Department of Energy or DOD or FAA, Nuclear Regulatory Commission, whoever we've got to talk to. So we have a plan that gets us through that, and we know who the people are, the players that get us through that. And we've all lived the dream on the bureaucracy side, so we know what's required.
And I think you mentioned it, but there's specifically an executive order supporting commercial launch of nuclear material.
Yes, that's correct. There's that. Let's see, there's NSPM 20, right? The
Right.
memorandum from, back in the previous Trump administration. All of this was intended to streamline how we go do space nuclear launch. It's basically brought it down from presidential approvals all the way down to agencies. And in this case, if we want to go launch something, if we get a commercial customer who wants to go to, say, geosynchronous orbit with a spacecraft, and they want us to help them get there, we're going to go through FAA to do that, and I have every confidence that that process will be a transparent, reasonable one that we can get our arms around.
Great. Second question from the audience. What's the minimum scale of a NTP system that Dark Fission is designing for an orbital tug system that would have to refuel in orbit?
Yeah, so I was really concerned about this when we started up because I see people shooting a little too high in the mission analysis. They tend to want to put only big payloads places, or let's go for Mars and put manned missions and hundreds of metric tons. And don't get me wrong, NTP looks really good in those scenarios. They look really good. In fact, they look really good even when the NTP system sucks, when it's just big and bloated and nasty. But it still looks good because its performance is so good. So it can outweigh things like the fact that it weighs too much. When we started, I wanted to make sure we had a really solid dynamic range for our mission analysis so that we weren't just going after really big missions. We realized very quickly that the way to do that was to come up with a very compact, lightweight engine and reactor. And that's what we've done. And because we've done that, that means that we can service payloads that are just a few metric tons, right? A few thousand kilos. And that's on the order of things that we would send, like ComSats that we might send up to geosynchronous orbit. And so we close the business case really well, even down at that level. And I think that's important. I don't think you can make all your money off sending people to Mars. That doesn't make sense to me. The commercial model has got to include everybody else that wants to go to space and missions and markets that exist today. I can't wait on nascent markets, people living on the moon, mining asteroids. We're not there yet. And so I'm not counting on that. I'm counting on missions that exist today. And that means primarily commercial stuff that goes up above low Earth orbit and defense missions that are going to want to go everywhere between low Earth orbit and the moon.
Right. Very practical, needed soon. That makes
I think you
sense.
got to do it that way, Doug. If
Yeah.
not, we're going to be in trouble.
Yeah. Yeah. That's great. Another question. Does Dark Fission's NTP system ionize the propellant, and does that result in radioactive exhaust?
No, we certainly saw this during the rover Nerva stuff back in the last century. The hydrogen that comes out the back end, that's not radioactive. That's not a concern. Although, everybody wanted to go ahead, in the 80s and 90s and just can all that effluent up and store it in some tank somewhere. I think that was just silly overkill. So no, there's no concern about ionization or other transmutation or something that's happening in the propellant. That's not a worry. I will say you don't want to stand next to it when it's running, but we don't intend to have anybody standing next to it when it's running. So that's not the worry. And we're not in the words of a recent NASA administrator nominee. We're not spewing radioactive materials everywhere. That's goofy. That's not happening. There's no plan to do that, and there's no reason to do it. So.
Okay. And why hydrogen?
Well, okay. So we talked about this a little bit earlier. The reason we're going with hydrogen is just falls right out of the rocket equation. It turns out that the best thing you can heat up in a nuclear reactor like this and basically force out the back for thrust is something with the lowest possible molecular weight. And it turns out that that's hydrogen. That's diatomic hydrogen, and it's great. Unfortunately, diatomic hydrogen is annoying because it's really low density when stored as a liquid. Some ridiculous fraction of the density of water. I think say it's what, 70 kilos per cubic meter. So it's, less than 10% of the density of water. It's very low density, which means that tanks can get big and you have to store it cold. So we have to deal with those issues. But hydrogen is absolutely the best thing for this. And if you don't go with hydrogen, you can certainly look, as I said, at other options, methanes, ammonias. There are other things that are out there, but they will degrade performance. So.
Okay. And what about timelines? In the ideal world, what does dark fission look like 2025 to 2030?
Yeah, I appreciate that. So what we want to do, we have a 5-year ops plan that we've been trying to get moving for a couple of years now. And the good news is we are now on track to that. We have we have an always be flying mentality. This is what we want to go do. We want to get flying immediately, and we want to keep doing it until we've demonstrated the capability fully on orbit and are in operations. So we have essentially a 3 demonstration program lined up. I alluded to this earlier. We have a program where we're going to put up essentially just a little bit of fissile material and squirt a little gas through it and get it hot. That's mainly to solve some of the regulatory agony because we know that nobody's done this in a very, very long, well, nobody's put up a reactor from the US since 1965. And certainly nobody's tried to fly a nuclear thermal rocket. So we will be doing a lot of pathfinding, and we want to make sure that we're sitting down with FAA and all of the interagency folks so that we can run this on a fairly simple case before we make it hard. So we'll do that first. Then we'll come back and we'll build an orbital transfer vehicle with I would call it a fake reactor, a proxy reactor. It'll look just like the reactor. It'll get hot, but not via nuclear fission. And we'll pour gas through it and basically use it like an orbital transfer vehicle, like a space tug. That's our Dark Ranger mission. And then the third and final, the capstone, is one with a full up Dark Force reactor, 5 to 25,000 pounds of thrust, and off we go once we've done the demo with residual capability for customer missions. That's a 5-year program, 3 space demonstrations. And while I haven't talked about it, there's a fair amount of groundwork that has to be done underneath all that to make sure that all the gear is going to work. So we're going to go out and test non-nuclear in the desert. We're going to go to a reactor, perhaps at Idaho, MIT, Oak Ridge, and make sure that some of the main components work in a nuclear environment. All those things have to be done to give us confidence that the whole system's going to work. And at the same time, we've got to make sure that safety is right up front. And so we're going to be conducting reviews and analysis and make sure that all that gets into the design so that we don't have issues that could crop up, such as, hey, if we launch this reactor and there's a launch failure and it falls in the water, is that a problem? Because it turns out, that's the problem for many reactor concepts. We've already addressed that, but we need to validate that with our FAA comrades and such, and make sure that they go and say, yeah, that's right. You could drop this thing in the drink and nothing bad will happen. Those are the kind of things we have to look at alongside the technical.
I mean, that's a logical sequence. And so when you go from the non-nuclear to the dark force, that dark force reactor seems like a really key step. When do you think that's happening, ideally?
Yeah, we want to do that in 2030. That's our
2030, that
culminating
would
mission.
be
Yeah. So we think
okay.
we can get to that first mission, that Dark Scout mission with just a can of fissile. We think we can do
Mhm.
that in 18 months. That's a quick run. And I
Okay.
identified where we can get the fuel. We know exactly how we would put something like this on orbit. We get a little microsatellite and jam that fuel on board and go. That is not in any way a hazard from a radioactive sense. So a lot of the regulatory pain that we'll see downstream, we don't have to face, but it's a way for us to kind of handhold each other into it so we all understand what questions are going to be asked and what analyses have to be done. So that's why we're doing that. And then the middle one, that's, building an orbital transfer vehicle is no joke. I've done it with a team before, and so
Yeah.
it is a lot of work. But I think that paid dividends, and I believe that that's going to be a very key step before we put the reactor on board to make sure we understand just how we move around. What are our procedures going to be? We're going to be handling a nuclear reactor for God's sake. We need to make sure that we can prove safe, reliable operations while we're on orbit.
And if I'm hearing you, this all goes up on Falcon 9 or similar launch. You're not relying on Starship or anything.
No, no, I think we can do pretty much all this with the existing vehicles. The first one is a little, it's a little microsat. We can do that as part of SpaceX's transporter missions or use one of their competitors. The second one, we'd probably have to reserve a little more space, and the third one, a little more space. But yeah, there's nothing that requires Starship to do any of this. So.
And
Not
someone's
that I wouldn't
asking,
take it. I'll take, I mean, great. Let's go.
yeah, yeah,
I love
nice.
what I saw the other day. That was beautiful. I was just
Yeah.
absolutely grinning from ear to ear. I just love what SpaceX has done there, and I just hope they keep getting better and better at it. So,
Well, and maybe a potential customer for you, right? Potential vehicle for you,
or partner or something. We'll see.
right?
Who knows?
So another question that's asking about dual use.
Dual use, like military, civilian.
Yeah, military applications. Clearly, orbital transfer applies to a lot, but what are your thoughts
I
on
mean, that's why we
military
started the
uses?
program at DARPA.
Yeah,
DARPA wouldn't have done the program at all if it hadn't had defense applications. And so, one of the things we saw was that rapid mobility on orbit is something that we just don't have. Nobody really has. And our adversaries are making strides toward it faster than we are. If you've been following the news of late, you'll see, people are doing interesting refueling operations, moving around in geosynchronous orbit. And the people that are doing that don't have American flags on the sides of their satellites. So, we need to do this. We need to be able to get out and about between here and the moon from a defense standpoint. And this kind of system is actually ideal for that, which is why we started the program at DARPA.
great. So another audience question: you have VCs who are interested in this. They want to get in this field. They're not technical. Besides talking to experts in the field, hearing you speak, are there any key like seminal papers or tools that someone should look at to get a sense of this, what this looks like as an investment?
Yeah, I mean, there's a lot of there's a lot of literature out there. And by the way, I think one of the best introductions to this area is a great website. It's an amateur website, right? There's somebody out there who tends it. I don't know who does it, but it's called Beyond Nerva, and I think it's just at beyondnerva.com. It's a great read. Um, I've been through it several times. I don't find hardly any inaccuracies in it, but it gives you all the context, historical and otherwise, as to why anybody ever cared to go do something like this in the first place, and all the work that's been done, since the 50s on the concept. All the work. It's good. So if I had to start somewhere, I'd start there. Um, and of course, I would talk to experts. I will say though that the nuclear experts are interesting because they usually settle on one particular brand or flavor of system, and then the rest of them are all bad or evil. So you just got to watch out
Right.
for.
Right, get the camps setting up.
Yeah,
That's a
yeah.
great website recommendation, Beyond Nerva website. So I'm going to look at that
That
myself
is
after
well
this.
worth a look. I
Yeah,
love it. And it's fun because I get to look back and go, oh my, I remember that. Oh God.
great. Uh, there's a somebody asking about competitive landscape.
Yeah. Well, if we're talking about competitive inside the space nuclear regime, that's one thing. If we talk about sort of the broader brush, I mean, I can speak to both. At one point a few years ago, well, I got asked a lot, why would you guys do this if DARPA is running a program and awarding money to primes like Lockheed and Babcock and Wilcox, BWXT? Why do you think you have a shot? Why does some startup, think they can compete? I'm like, are you kidding? Are you kidding? Have you ever dealt with BWXT or Lockheed? Like, come on, guys. Startups can run rings around some of these large contractors, and no mistake. So that does not worry me. But I will say, with the cancellation of DARPA's Draco program, we got kind of an open field. There's not a lot of competition sort of inside the space nuclear industry that to speak of. We've lost one of the startup players. They went bankrupt. I believe they got bought out. That was the ultra safe crowd. I believe they got bought out by a group called Standard. I just haven't heard a whole lot to say as to where they're headed and what they plan to do. But the ultra safe guys are moving right along, on the NTP path, and they're out. The Draco folks, they're primes, and typically when primes don't have money anymore, they just wander off and find other things to get the federal government to pay for. So I'm not particularly concerned about them from a competitive standpoint. We have quite an open field for nuclear thermal, to be perfectly honest. It's not looking too bad. We've got players out there, I think, that are more like partners than anything else. X Energies, you know, um, General Atomics. These are all folks
Right.
who help us with things like fuel forms and the like, and that's all great stuff. I mean, I think we could
Yeah.
really capitalize on the innovations coming out of those folks. So that's all goodness. But in terms of inside space nuclear, I'm not seeing a heck of a lot right this minute. If you'd asked me 2 or 3 years ago, I would have had a completely different story. Now,
Yeah.
broader brush, yeah, there's all sorts of stuff that's out there. You got folks like Tom Mueller sitting over there at Impulse Space doing chemical propulsion. My old company Momentous is looking at doing space tugs, with
Yeah.
with water as the propellant and things like that. Um, I'll just be, less than bashful and tell you that we're going to beat the crap out of all that. Our performance is going to be so much better. We're going to be so efficient and so quick. I'm not worried. The only thing I'm worried about is getting it on orbit in the first place. Once it gets up there, once the proof of principle is there, it's going to get used and used a lot because it's going to be really good. Um, so I'm less concerned about that, but we do have the hump to get over because it is space nuclear. And so, the
Right.
difference between funding somebody who's got a little chemical rocket and somebody who's got a reactor, that could be enough for some investor to say, that just scares me and I don't know what to do about that. I'm like, well, all I can say is get super educated on it because nuclear is where we're headed, one way or
Yeah.
the other.
Right.
And you can either jump on board or hide, but we're going there. It's not going to always be easy, but we're going to get there. So,
Yeah, I mean, and as you say, there's a lot of synergy between the different propulsion companies. We're going to use all the forms. We're going to use all the types of nuclear energy. And then when you're talking about MPP, dark fission is right in it.
yeah, and folks like Tom, holy cow, that stuff's going to get used. We're not going to have one kind of thing to do anything. This is going to grow organically, and people are going to get to compete and cooperate in various ways. And I can see that happening. I can see folks who are doing chemical, hybridize, and I can see it go the other way. So it's going to get interesting.
Cool. Well, we got another question here that may be helpful. We do these webinars to, get exposure to these companies and get people interested in investing and VCs, but there's also people that sign on, and we see this a lot where we've seen the space economy picking up, and now people who have a longstanding interest finally see that maybe they could get into it, but they don't know how to do it. So it's just a career question for an individual, and maybe there's
Yeah.
more out there listening than just this one person. But this person says, I'm a former nuclear submarine officer with a BS and an MS in aerospace engineering. I've been
Cool.
out of the industry
Call
for
me.
25 years. I want to come back. How do I get technically competent again?
Well, I'd have to judge the technical competence, but I like the initial foray into where you've been. Um, Look, if you haven't done space before, right, specifically, then that's going to require some work. But if you've got the nuclear background and if you've got that smattering of aerospace sitting there on top of it, I think you probably have most of the fundamentals to do pretty much the work we're doing. I'll be really clear. I'm building a heat exchanger. That's what I've got. At its fundamentals, I'm building a heat exchanger that I want to pass gas through and get really hot and blow out a nozzle. I mean, at its conceptual level, this is not craziness. We know how to do this. I'm not trying to build, the core of the sun here.
Well, well, this has been really
Please put that
interesting.
person in touch with me because they might be surprised by how much they do know.
Okay, so Leland, if you're still listening, you can reach out to Dr. Kennedy here
Please
for
do.
more. Uh, okay, someone's asking about if the canceling of Draco is saying anything about the demand signal for NTP.
Well, look, I don't think so. All right. And there'll be people who debate this, but I really don't think so because the demand signal isn't about a technology, it's about a capability. And the capability is rapid, efficient transport somewhere between here and the moon and perhaps beyond. We need that. Space Force needs that. NASA needs that. Commercial sector needs that. That's not going away. And so when someone says there's no demand signal for NTP, I'm like, so you mean there's no demand signal for moving fast and efficiently? I don't buy that. Okay. Now, if DARPA says they had to cancel their program because they're not sure the demand signal, that's, they can cast it how they like. But I was at DARPA, and what I will tell you is when programs get old, they get canceled. That's just the way of it because DARPA has very high turnover in both its leadership and its program management. And everybody comes in there to make a difference. And they don't like to come in there and make a difference with some program from 4 administrations ago that's been, sucking up somebody's portfolio. I got to run an office there. Which programs do I like the most? Probably the ones that I got to start, right? The ones that I had to finish from 10 years ago, those may not be the ones that I'm so thrilled about. And that's just human nature, and that's just how this stuff works. So Draco got old, it got expensive, ask the primes themselves. And I think in the end, that's what got it canceled. So sorry, I get it. It should have been done in 3 years for 300 million.
Got it. Okay. So this has been really interesting. I think I want to make the final opportunity for you to just share anything else that you haven't had a chance to cover. But for my last question, I just want to ask the basic, why should an investor invest in Dark Fission? What's the investment case?
Well, Doug, it's interesting. I mean, I've been kind of off the whole solicitation of private funds. I started that way, right? My co-founders and I, when we started off, we said, you know what? Fickle government, man. We just don't buy that they can get to the end on this. They've failed multiple times. But if we could get private dollars into this and get us to the end, the traction we're going to see with all the customers is just going to be there, and I have no worries about that. But it's been a difficult sell, yeah. It's been hard to come to VCs and say, "Hey, space nuclear, you should just jump in." So as a result, we have opted to go after some government monies, and we're getting it from real customers. NASA's excited to come to work with us. We'll hear more about that, I think, in the next year. And as I said, we have Space Force money, and we're hoping that we're going to be able to leverage that Space Force money into StratFi opportunities and other things. So I guess what I'd say is if you want to be a part of the future space economy, this is the future of space, okay? This is where we're headed. We've got to use nuclear to go do this stuff. It's not just about power, it's about propulsion. This is how we are going to get out into the solar system and make it ours. If you want to wait. You can wait for fusion too if you want. I don't have a problem with that. I think fusion's fascinating and I hope it works. But if you want something that we know how to do now, we know how to build fission reactors right now. So let's get up, let's get flying. And if you want to be a part of this, by all means, give me a call. Like I said, I've got I've I've got money from the government right now to go do this. There's clear interest. So I'm not particularly concerned about that, but I'm always available to chat with investors who are excited about this and want to help us move forward. So.
Yeah, it's money, and it's also a signal that there's interest since you've got that
Yeah,
traction.
we got real traction. I'm not worried about that. The previous comment about, is there a demand signal problem? Like, no, there's no demand signal problem. But, when you cast it in the sense of, do you want to be able to get around? Do you want to be able to move quickly? Do you want to be able to do it inexpensively,
Yeah,
efficiently? The answer is, of course you do. We wouldn't opt for walking to work if we can drive or take a
yeah.
bus or, we don't take, when was the last time anybody took a boat from I don't know, the UK to New York. I don't think anybody's doing that anymore. I don't think the business case for that's been around for a long time. And it's not because you can't do it. It's because it's not fast and efficient. And fast and efficient is what people generally like. So
Yeah, yeah. Yeah, well, Fred, there's not a lot more cooler topics than advanced propulsion in space.
I'm
So
with you.
this has been a lot of fun
Thanks, Doug.
and great
And so
information.
I want to hear about what you've been doing as a neurologist.
Yeah.
I want to know more. We could talk offline
Yeah,
though.
we'll talk after. That sounds good. So, is there anything else you'd like to share before we finish up?
No, I just want to let you folks know that look, I'm super excited about finally getting this stuff going. I think we've got the opportunity finally to get it done. I think we have the customer traction to go get it done. I think we have the network to go get it done. This is a good time. I'm actually quite pleased. If you'd asked me 3 or 4 years ago, I would have been concerned, but I really feel like we're starting to make real progress on all fronts. And I think if we do this in an agile, rapid way, I think we get to the end and we get to the end when we need to really service this customer base. I don't want to waste time on sandboxes. I really don't. I don't want tech maturation programs. We just want to go make a capability that works. We can make it better later. We just need to get it to work now.
Cool. Well, Fred, thank you very much, and all the attendees. Thank you, everyone, for joining.
Thanks, Doug. Thanks
Great
to you,
topic.
Nate.
Yes,
All
thank
right.
you everyone for joining. And yeah, we'll be in touch soon. And if you'd like to get in touch with Fred, feel free to reach out to anyone on Valerian or Fred.
Yeah, I'm happy to chat with anybody, especially this individual who has an interesting resume. So let me know.
Yeah, we'll connect you guys.
Outstanding.
Great.
Thanks a bunch.
All right.
See you
Thanks,
guys.
everyone.